So in our last lecture, we used PWM signals to fade an LED in and out using two for loops, one for loop to fade it in and one for loop to fade it out. What this looks like on an oscilloscope is a signal that gradually increases and decreases its duty cycle in a cycle, like this. The code was fairly straightforward if you're comfortable with C, C++. And in this lecture, we're going to look at applying this on a DC motor. So you might just have the instinct to run your motor through the microcontroller. There are a couple of reasons why this is a bad idea. One is the microcontroller doesn't have enough power. So it's at 5 volts, maybe 20 milliamps. That's 5 times, so that's 100 milliwatts. Whereas a DC motor might require 1 watt, 2 watts, 10 watts, 15 watts. And the other one is when we turn off the voltage on the pin, the inductive load will still induce a back EMF that'll run through the line and back into the microcontroller, and it might destroy some critical components in there. So we need a different way to drive our motor. I like to use well, first of all, I like to protect my circuits, so I'll just put a diode that so once we turn off the DC motor, there's still a loop for the current to go through. So a lot of current is going to go through into this red terminal, and it's going to go through the motor and out through the black terminal. And if we just shut down the motor, that current will continue through the black line and through the rest of your circuitry. But by putting this diode here, we'll actually have a little loop which the current can just go through and not damage the rest of the components that are over here. We're gonna need a couple of things. We already have the code. We're gonna need a diode, we're gonna need I like to use a MOSFET. We can go with the NMOS. And this is gonna be our gate signal. Alternatively, we use a voltage divider on this. So we're just dividing the voltage by half in doing this. So the PWM signal is going to come to this node. It's going to be divided by 2 here. That signal is going to be 2.5 volts at its peak here. It'll go into the gate, and the gate is going to switch the source onto the drain. I have a video on this where I kind of loosely go over transistors that you might want to check out if you're unfamiliar with the workings of those. We're going to need a power supply, and this is what's going to drive our DC motor. This is the module that has enough power to drive the motor. Alright, so the power is going to go through here into the motor. It can't go through the diode because it's pointing in the wrong direction. So the current is going to go in here through the circuit. It's not going to go back up there because the potential is higher on this side than on that side. So it's going to go down, and we wanted to go, so on the NMOS it's going to go from the drain and out through the source. There we go. Now let's try out our code. Okay, so let's take a look at what happens. At our maximum point, we get about almost 100 milliamps, which is our desired current. Let's see the highest RPM. 11,000 RPMs. Yeah, a little over 11,000. So this is a cool way to rev up and rev down an electric DC motor using the Arduino, power supply, and an NMOS. Thank you for watching. This is the circuit I built. So we have the Arduino on the left. The pin is gonna toggle the PWM signal, and that's just going to go straight into ground through 2 I just use 1K resistors. And make sure you tap the node between the resistors, because that's our voltage divider, and send that into the gate. And once the gate is toggling on and off, the transistor is going to open, and the channel between the drain and the source is going to open up, and it's going to start leading more current through it. So we see the power supply on the right. That's going to send power up to the left, and then down through the motor. It's not going to go through the diode, it's just going to go through the motor. It's going to turn left through the transistor into ground. When we shut off the gate voltage, there's no current going through the transistor, and we put the diode on the motor just to have a little current loop, so that the excess current can just fade out in this little loop right here, so that we don't damage any circuit on our breadboard, and in this case the transistor. Alright, thank you for watching. I hope you learned something. And yeah, thank you.